This video will cover our geometry review day 3, the first 5 questions, so that'll be 21 through 24, and then starting with number 1 from a new test. Again, all in the same packet though. So flip it open and we'll get started. 21 says in the diagram below, the triangles are similar. When triangles are similar, that means that they have the same angle measure, but the sides are in proportion. Where we have a fraction equals a fraction. So we're going to label it all up. It says AC is 12, DC is 7, DE is 5, and the perimeter of triangle ABC is 30. What is the perimeter of triangle DEC? So I'm going to choose to call that X because we don't know what it is. So I know if I take my similarity statement, I can stack the letters. A, B, C, D, E, C. Just writing them out the way that I see them. So I know that segment AC here, A to C, matches with segment DC. Because again, A matches with D, C matches with C. So knowing that, I can place 12 over 7 because I'm going to go from the big triangle over the small triangle. You could also flip-flop that and go small over big. It's your choice. And now when I look, I also have a perimeter of the big triangle, which matches the perimeter of the small triangle. So equals 30 over X. Notice that I'm not using this 5 over here. Sometimes they give you extra information, so we don't actually need that. So we solve proportions by cross-multiplying. 30 times 7 is 210, is equal to 12x. You will get a decimal for this problem. So now we get x equals 17.5. Choice 4. Okay, so 22 says the line 3y equals negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? So a couple things to know about dilations of lines is that they have the same slope, but a new y-intercept. And to find the y-intercept, we take it and multiply by the scale factor. They did not give us a scale factor in this problem, but we can still find the new equation by looking for lines that have the same slope. So the first thing we want to do is get the equation into y equals. So we have 3y equals negative 2x plus 8. So we divide by 3 on both sides with every single part. These ones cancel, so we have y equals negative 2/3 x plus 8/3. So I know that I want my slope to be the same, negative 2/3. So when I go through my choices, like choice 1, we have 2x plus 3y equals 5. I'm going to solve that for y, get y by itself again, and see if it has a slope of negative 2/3. So we're going to subtract 2x away. We have 3y equals negative 2x plus 5. Divide by 3. And when I cancel, I notice that I have a negative 2/3 x. That's exactly what I wanted with a brand new y-intercept that changed by some scale factor, which we're unaware of. We don't know what the scale factor is. So I am going to choose choice 1, but I would still like to look with you at, say, maybe choice 2, so you can understand why it might not be choice 2. 2x minus 3y equals 5. So I'm subtracting away 2x again. And we have negative 3y equals negative 2x plus 5. I divide by negative 3. I cancel, and we are left with y equals negative divided by negative turns positive, so positive 2/3 x minus 5/3. And you can see here that this slope, 2/3, is not the same, remember we wanted same slope, as what we had in the original equation. So choice 1 is the answer for number 22. Number 23 is actually a very weird question. It says a circle with a radius of 5, so I'm going to draw that in on here, was divided into 24 congruent sectors. Sectors are just like slices of pizza or pie. The sectors were rearranged as shown in the diagram below. To the nearest integer, that means a whole number, the value of x is blank. So here's x down here at the bottom. And it looks like, if I undo my writing, it looks like it's made up of the curved portions. Curved portions. So when I go backwards, I see curved portions are here, so this whole thing is x. Curved portions are here, so this whole thing is x. And those curved portions were here, meaning this whole thing here is x. So that to me looks like I took a circle's outside edge and cut it in half to get x. Well, the outside of a circle is called the circumference. And so x is equal to half of the circumference. If you use your reference sheet, you'll notice that we have a circumference formula, which can be represented by 2 pi r. C equals 2 pi r. And we know the radius to be 5. So I have 1/2 of 2 pi times 5. That entire value can get typed into the calculator. 1/2 times 2 pi times 5. Really, this reduces to 5 pi because the 1/2 and the 2 cancel. So this gives me x to be equal to 15.708. And it did say to round to the nearest whole number or integer, so 5 looks to the 7 and becomes a 6. Choice 2. Flip it to the next page so we can see 24. So 24 says, which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? Now, if you recall, triangles are congruent by 5 different methods. The first being side, 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 SAS, side, angle, side, ASA, AAS, and of course HL, which is only used with right triangles. So we're going to kind of knock HL out of the way here because these triangles are not right triangles. They did not tell us that. So when I look at choice 1, it says AB congruent to DE. So I'm going to mark up my diagram, and if you have a pencil, then I would consider marking up yours as well with me. If not, then just follow along with what you see on my paper. AB and DE, they match, so that's cool. That's a pair of sides. BC and EF, they match, so that's a pair of sides. But SS is not enough to conclude, so we're going to get rid of choice 1. Okay, choice 2 says angle D is congruent to angle A. That's a pair of angles. Angle B is congruent to angle E. That's another pair of angles. And angle C is congruent to angle F. That's another pair of angles. So this here is AAA. That's only okay with similarity. AAA is never okay with congruence. Okay, the next one, I can't erase my red markings, unfortunately, on the picture because I paused the video for a second. The next one says there's a sequence of rigid motions, like a translation, reflection, or rotation, that maps AB onto DE. So that's cool, that's parasides. BC onto EF. That's awesome, another parasides. And AC onto DF. Fabulous, a third parasides. So this is looking like SSS. But let's take a look at choice 4 because it's always very important to check all of your choices. So if I erase my markings, hopefully, nope, doesn't look like it. Oh well. So when we look at choice 4, it says that there's a rigid motion that maps point A onto point D. So I'm going to take this point and map it over here. Then I'm going to map this entire side length, AB, onto this entire side length, DE. So that's a pair of sides. And then I'll map this whole angle B onto this whole angle E. So that's a pair of angles. Now you might be thinking, well, this looks like ASA. But it's not, because I'm only mapping point A onto point D, not angle A onto angle D. If I redraw this picture up top, I have B, A, C, and I know that this side and this angle are congruent to angle E and side DE. And I know that point A gets mapped on to point D. But what if I extend this side length way down there, and I keep everything else the same? This creates triangles that are no longer congruent. I kept A to map onto D, and I kept segment AB to map onto segment DE, and angle B congruent to angle E, just as they told me. But F is way out here, meaning that the triangles don't have to be congruent. This is technically only SA. So choice 3 is the valid choice here. So our last one for this video is number 1. This comes from a brand new test. I believe it's August 2015. A parallelogram must be a rectangle when it's blank. So we're going to sketch a parallelogram, and we're going to sketch a rectangle. And I noticed that they're talking about diagonals in the pictures, or in the choices, so I'm going to draw them in the pictures to the best of your ability. So when I look at changing a parallelogram into a rectangle, I want to ask myself, what is unique or special about a rectangle? So the first one says the diagonals are perpendicular, meaning where they cross, they should make right angles. When I look at the diagonals and where they cross, they clearly do not make right angles. So that's definitely not true of a rectangle. The next one says that the diagonals are congruent. So from here to here must be congruent to the other set of diagonals. So that looks like it might be true. The next one says opposite sides are parallel. So yes, this side is parallel to this side, and this one is parallel to this one. I could certainly mark that up. But it's also already true of a parallelogram. So this is true already of a parallelogram. So I don't want to choose it because it's not a special or unique property that would turn it into a rectangle. So choice 3 is gone. Choice 4 says opposite sides are congruent. Yes, this side's congruent to this side, and this one is congruent to this one because they're opposites. But again, that's already true of a parallelogram. So the only choice that's unique is choice 2. Diagonals are congruent. You can see here in the parallelogram, this one's very long, whereas this one is shorter. Okay, so check back with the next video so that you can see the next couple of questions worked out in the multiple choice section.